Okay, in Unit 2, we are going to be graphing all 6 trig functions and then talking about the inverse functions where we're solving for theta. Unit 2 reference sheet is just the unit circle. We don't have any formulas in this unit, okay? So I am going to tell you that my notes on this is slightly different than what Alex does. And the reason being is I think the format that I use is a little simpler and a little bit easier to follow. If you go through Alex and like their method better, feel free to use that way. I can work with either way. I just find that the method that I do is a little bit easier for the majority of students. 4.5, we're just going to be graphing sine and cosine functions. These are going to be our 5 main points, okay? I normally do that because what I like to show is when I show the unit circle, you can see that this is cut up into 4 parts. Well, in order for it to be cut up into 4 parts, there's 5 pieces. This is going to be 1, 2, 3, 4, and to complete, we go back to this one again. That's 5. So there's 5 parts, starting with 0, pi over 2, pi, 3 pi over 2, and then 2 pi to complete it. Okay, that makes this whole section available. Okay, so those are the 5 numbers that I normally will use. I won't be using these additional sections. And basically that's here, pi over 4, 3 pi over 4, okay? Here we have the table, okay? So x is going to refer to our theta in terms of radians, and then y will refer to our sine function. So if you look here, and we'll just show you real quick, if we have 0 radians, sine of 0 is just your y, is 0, okay? Going on, sine of pi over 2, here's pi over 2, remember sine is y, is 1. Well, there's our 1, okay? Sine of pi, here's pi, sine is our y, which is 0, okay? And then here, sine of 3 pi over 2, there's 3 pi over 2, is negative 1. There's my negative 1. And then we're going back to 2 pi, which is the same thing as 0, because those are coterminal angles. So we got 0 again. So when we're plotting these, all we're doing is plotting the theta in radians and our y value, which is the sine of whatever theta it is. So 0, 0, right here. Pi over 2, positive 1. Pi over pi, 0, there's our 0. 3 pi over 2, right here, negative 1. And then 2 pi, 0 again. So this is what our trig function looks like for sine, okay? A couple of other things you should notice here is that sine has a period of 2 pi. Once it gets here, it's going to follow the exact same shape throughout. So it's going to be consistent. And y goes anywhere between negative 1 and positive 1. So this is going to be our range, okay? The domain will be 0 to 2 pi or all real numbers. If we're looking at one period, it can be all numbers between 0 and 2 pi. If you're looking at the entire course of the graph, it's going to be all real numbers, okay? All right. If we were to go backwards, you will see that this goes in a downward direction, and that means it is an odd function. Okay. Now let's look at some of the properties of cosine. Here is cosine. Well, we're doing the exact same thing, except remember cosine means x values. So cosine of 0, remember that's your x, that's a 1. There's our 1 here. Cosine of pi over 2, 0. Okay. Cosine of pi, negative 1. There's my negative 1. Cosine of 3 pi over 2, back to 0, and then cosine of 2 pi, again, that's coterminal with 0, that's just 1, there's my 1 value. Okay. On this one, you can see that the domain is all real numbers. The period is from 0 to 2 pi. Once it hits 2 pi, it will repeat the pattern that you see here. Okay, so domain is all real numbers, the period is 2 pi, and the range, which is our y value, is also between -1 and +1. We always start with the lowest numbers first, okay? All right. The difference here is if this one were to continue going backwards, this is going to be an even function. If you remember even function, if I go forward 1, it's 0. If I go back -1, it's also 0. So it's the same values. If I go forward pi/4, you get a positive value. If I go back pi/4, you're going to get the exact same y value. This is what even functions look like. Over here, I'll just explain it a little bit similar. It's the same thing, except look at this. When I go forward pi/2, I get a +1. If I go back pi/2, I'm going to get a -1. So even though the y values are the same, they have the opposite signs. Okay? So that's the difference between those two. If I were to graph those two on the same graph, this is exactly what it will look like, and you can see that there is a lot of similarities between these two. The only difference is it's shifted by pi/2. Okay, that's our horizontal shift. You should remember your transformations, or if you do remember your transformations from college algebra, this part should be a lot easier. Okay, here's the information we just talked about. We're going to go ahead and go on to a basic graph. So here's our basic graph. All we're doing is applying an A now, or an amplitude. Before we were just saying y is equal to cosine x, or y is equal to sine x. We didn't have an A in front, or a number in front of that trig function. That A tells us how high the graph goes or how low it goes. All right? So if A is a positive number, you're going to be going in an upward direction. Okay? If A is a number between 0 and 1, that means that your graph is shrinking. Okay? So let's pretend that this is an actual unit of 1. If I multiply 1 by 2, it's going to double in size. Okay? Here's my unit of 1. If I do half, it's going to shrink. Okay? That's what this part is saying. All right? And then if it is a negative value, remember negative says direction, then it's going to have a reflection. Instead of going up, it's actually going to be going down. Okay, so it is going to be reflected about your x-axis. All right, so A is going to be your amplitude. Let's determine our amplitudes here. Identify the amplitude for each function. The amplitude is always going to be a positive value. So here I can say the amplitude, or A, is equal to 8. If you put a -8, you're going to get it incorrect. The amplitude here is going to be equal to 2/3. Okay, so all you're doing is looking at the number only, and that will be your amplitude. The negative tells you if it's reflected about the x-axis or not. Okay? Now let's go ahead and graph this one. So here it says graph the function. The way that I'm going to do this is slightly different than Alex. Okay, so I am going to list a few of the things first. First I want to say is, what is A? A in this case is going to be 2/3. So I'm going to go ahead and put 2/3 there. Okay. The next thing I'm going to want to do is determine where the function starts at. So I'm going to put here starts at. Okay, so let me help you with this. When we're doing this one, let's go back to the first page. Okay, when I'm doing this, I want you to notice that there's a few differences between these two graphs. Okay, here we have a top. I'm going to call that T. We have a bottom, okay, and we also have a center. I'm going to make that pink. Okay, all right, so for our sine graphs, for our sine graphs, the graphs will always start in the center. If there is a reflection, it will still start in the center, but it will be going down. Here there's no reflection, it goes up. Reflection goes down. Okay? For sine, it always starts in the center. For cosine, let's go ahead and label our points. Here's our top. Okay? Here is the bottom. And of course, the center is right in the middle. Center won't always be on your x-axis. I want you to realize that, but for right now, it will be. For your cosine functions, the graph will always start either at the top or at the bottom. When it starts at the bottom, that's when we have reflection about the x-axis. So imagine if I have this graph and I flipped it. This point wouldn't be up here anymore, it would be down here. So for cosine, it's either going to start at the top or it's going to start at the bottom. So let's go back to our graph, and here we're going to ask ourselves, where does it start at? Does it start at the top? Does it start at the bottom, or does it start at the center? Because there is no negative in front of A, we are going to start at the top. So cosine always starts either at the top or at the bottom. If there's a negative in front of the A, it starts at the bottom. This is a positive value in front of the A, it's going to start at the top. So the first thing I want to do, and I will use my highlighters here, is I'm going to label the top and the bottom. Notice that there's no other numbers here, so that means it's going to start at the origin. So I'm going to go up here, and I'm going to go ahead and draw my line and say that this is my top. Okay? The bottom is going to be negative 2/3. All right? So A is just referring to the distance from the center to the top and from the center to the bottom. Now I can go ahead and plot my points. Okay? So if it starts at the top, this is going to be my first point. Okay? Right there. Alright, now I'm going to use the unit circle, and I'm going to plot the other main point. So if I started at 0, the next one would be pi over 2. Okay, so pi over 2 is right here, and if I start at the top, the next part is going to be the middle, or the center. Okay, then I'm going to go to pi. Pi is going to be at the bottom. So you should see a pattern. Okay, let's go back to our cosine over here, and notice here are the main points. So this is my first main point right here. Okay, second one, pi over 2 is 0. Okay, pi over pi, negative 1, there's my main point. 3 pi over 2, 0, and then 2 pi is back at 1. So I have these 5 main points. That's why I don't choose the ones in the middle, because that will be a little bit more difficult to find. I'm going to use the top, the center, the bottom, the center, and then back at the top. Same thing applies for your sine function. Okay, so now that it's at the bottom, I'm going to go over to the next one, which is 3 pi over 2, and that's going to go back at the center, and then 2 pi will be back at the top. This is used for periods that are functions that have a period of 2 pi. Here we don't have any other numbers, we just have an A, so that's why I chose the parts that are on the unit circle. Once I have that, I can go ahead and connect the dots to complete your graph. Okay, so it'll look something similar to that. Alright, the next problem. The next problem has y is equal to negative 2 sine x. Okay, so A is equal to 2. Okay, notice there is a reflection here. All right, so and we're using sine. So sine starts where? Well, let's go back to our original graphs. Here's our sine function. Sine will always start in the middle, in the center. So when it starts in the center, we have to decide, is it going up or is it going down? when there is a negative in front of the A, you're going down. If it's a positive in front of the A, then you're going up. Okay, so let's go ahead and use our points. Here A is 2, so I'm going to start my top going up 2. The bottom is going to be negative 2. And of course your center is going to be along the x-axis. Okay, so I'm going to go ahead and put my center here. I should have done it for the other one. I'm going to go ahead and do that now so you can see those points better. Okay, so now that I know it starts in the center, I'm going to go ahead and put my first point at the center. Okay, period is still 2 pi here, so I'm going to be using those exact same points. Okay, so 0, pi over 2, pi, 3 pi over 2, and then back to 2 pi. Let's go ahead and go to the second point. Second point is going to be pi over 2. Notice here I have to go down, so now I'm shifting down. Okay, the next point is pi. I go back to the center. Next point, 3 pi over 2, I go now to the top. Okay, next point, 2 pi, go back to the center. So our graph for this one is going to look like this. One complete rotation. All right. Another thing you can do, at least for at this time, right now, that will be okay, is you can graph some of these. So if I were to put this in my calculator, -2 sine, okay, make sure that you are in radian mode, which I am, because we're using these values. I can put 0. Let's start with 0. So here I'm saying if x is 0, y is 0, and that's what I have here. Let's go ahead and do the next one, which is pi over 2. I'm going to go up, and I'm going to scroll over, and I'm going to say pi divided by 2, and close the parentheses. You can see now I have a -2. Well, here's my pi over 2, here's my -2. If you can continue going through, I'm going to skip this one, but I'm going to go to the one over here. So I'm going to go here, and I'm just going to include a 3. So I'm going to insert a 3. Okay. When I press enter, you can see that becomes 2. So when x is 3 pi over 2, you have a +2, which is right here. Okay, and then so forth. Okay. So I know that this graph is correct. Okay, that's graphing the basic ones. Let's go ahead and go on to the next one. We'll look at another variable, adding b to our graph. A affects the shrinking and stretching in a vertical direction. B affects the shrinking and stretching in a horizontal direction. So our B determines our period. Okay, there's going to be a little bit of formulas for this, but you have to know it, and I'm going to go over that in the next part. Let's go ahead and do that here. All right, I am actually not going to do this method. I'm going to show you, I think, a slightly easier way, but again, if you want to use Alex and learn this method, by all means, you're more than welcome to do so. If you need help learning this method, let me know, and I will get with you on that. We will be doing something very similar with this method when we get to our tangent and our cotangent, because that would be the easier way to do it for those. All right. Okay, let's go ahead and write the information that we have here. All right. If you notice in this particular equation, we have a negative inside our parentheses. What do we know about cosine? Okay, hopefully you remember cosine is an even function. Whenever you have an even function, that means the negative can actually disappear. So I'm going to rewrite this equation to be y is equal to 2 cosine 4x. Okay, that means the exact same thing. If this was a sine function, which makes it an odd, the negative would be applied to the outside, saying that there is a reflection about your x-axis. Okay, so now what we're going to do is we're going to list the information we knew previously. A, amplitude, is equal to 2. Okay, From here, this point, I can go ahead and start graphing some of the information. At least for right now, I can. Okay. So I know A is 2. That means the top is going to be at 2. Remember, we don't have any vertical or vertical shifts yet. So here's going to be the top, and here will be the bottom. The center is still going to be along the x-axis. Okay. Now I'm going to say, oh, wait a minute. B is not 1 anymore. B is now 4. So here's the equation that you need to know for sine and for cosine. It will also apply to secant and cosecant as well. So the period is going to be equal to 2 pi over B. Since B is 4, I can go ahead and substitute that. 2 pi over 4, that means the period is pi over 2. That means by the time we get to pi over 2, which is right over here, it needs to go through a complete rotation. Okay. Now, remember when we're using our unit circle, okay, when we're using our unit circle, a complete rotation, we actually cut up into 4 parts. Part 1, Part 2, Part 3, and Part 4. We use 5 specific numbers to help us. So that's 1, 2, 3, 4, and 5. But the actual sections themselves, we cut up into 4 parts. So when I'm looking at the entire period, I'm going to say, well, I want 4 parts. So each section on the period is going to be cut up in 4 parts. So I'm dividing the period into 4 sections. Okay. That will get me pi over 8. Okay. Now, cosine. Where does cosine start at? Starts at. Cosine, hopefully you said, starts at the top or starts at the bottom. Because the sign before the A is positive, we're actually going to start at the top. Okay. There's no horizontal shifts, not yet. So what we're going to say is we're going to start at 0. Okay, so our first point is going to be at 0. Okay, our second point, we're going to take this number in the section part and we're going to add it. So I'm going to do this slightly different. I'm going to use my purple marker to mark our 5 points. Okay, so starting at 0, I'm going to take the section and I'm going to add pi over 8. Okay, that will get me pi over 8. This is going to be my second point. Okay. So basically what you're doing is I'm starting here at my first point, I'm adding my section, and I'm getting my second point. Okay. Now I have to add another section, which is pi over 8, and I will get my next point. This will be 2 pi over 8. Okay. That's going to be my next major point. Okay. Again, I'm going to add another pi over 8, and I get 3 pi over 8. Notice I'm not simplifying my fractions right now. All I'm doing is getting my points. Now, notice here, this is 1 section, 2 sections, 3 sections. I have gotten 1 section, 2 sections, 3 sections. So the number I have right here is just this one. So this is 1 number, 2 numbers, 3 numbers, 4 numbers. 1 number, 2 number, 3 number, 4 number. I need to add another section to get my last point. So I'm going to add another pi over 8, and I'm going to get 4 pi over 8. Okay, this is my last point. So by the time you get to your last point, you've completed one entire rotation. If I simplify this point, you would get pi over 2, which is what our period is. So these two essentially match. Let's go ahead and graph this part. I'm starting at 0, and I'm starting at the top. So I'm going to start my first point right there. Then I'm going to pi over 8, which is conveniently right here, and I'm going from the top to the center. Pi over 4, if I simplify this, I get pi over 4. It's going to be at the bottom. 3 pi over 8, back at the center. and then pi over 2, which is the same thing simplified, you're going to be back at the top. So our graph is going to look exactly like this. Okay? And that's one complete rotation. So here what we're doing is we're adding now another layer. We're adding a C and we're adding a D. So we have our vertical shrinking and stretching, our horizontal shrinking and stretching. We talked about the reflections, about the x-axis, and now we're going to talk about actual shifts. So this is going to be our horizontal shift, and this will be our vertical shift. Okay, so let's go ahead and continue with this section. Again, I'm not going to use this method. I think the method that I use is a little bit easier for the majority of students. Okay, number 6 says graph the function over one full period and identify the amplitude period and the phase shift. Okay, so the most important thing you have to realize is that whenever we have parentheses here, that tells us there's a number attached to the x that's plus or minus, that we do indeed have a phase shift. But don't get confused. This is not the phase shift. The phase shift has to be in a different form. If there is no parentheses here, then this would be considered our vertical shift. So there's, if you go back to the transformations, you have a vertical shift which tells it to move up or down, and then you have your phase shift which tells you move it left or right. Okay, so first thing you have to do when you're dealing with this problem is we are going to factor out this 2. The way that I do this one, the B needs to be on the outside of the parentheses. So here I would have x minus pi over 8. Okay. If I distribute this 2 back in, I'm going to get the exact same values that I have here. 2 times 1, 2. 2 times 1 divided by 8 is the same thing as 1/4. Okay. Now let's label our points. A is going to be equal to 3. Do we have a reflection? Hopefully you said no, because there's no negative in front of that 3. B is going to be equal to 2. Okay. What does that tell us about the period? Well, the period is 2 pi over B. Okay. So 2 pi over 2 is the same thing as pi. Okay. Now, remember, for us to get our sections is the period divided by 4. So pi over 4 would be our sections. Okay. Now let's go back and say, where does it start at? It starts at, this is a sine function, which means it starts in the center. Okay. And which direction does it go from the center? Well, because there's a positive 3, you're going to be going in an upwards direction. Okay, so our starting point here is not going to be 0, because remember we are talking about now a C here. Okay, this C determines our horizontal shift. The D outside of the parentheses, if there was one in this case, would determine our vertical shift. Okay, so what I'm going to do at this point now is I'm going to go ahead and label some of these points. We determined that there's no vertical shift, so A is going to be 3, which means we have a top here and we have a bottom here. Okay, center is still going to be in the middle on our x-axis. I'm going to go ahead and draw that out too. Our starting point on the x-axis, there's a shift now. Now, if you remember, pi over 8 is negative, but you always are going to start on the opposite point. So instead of going back pi over 8, we're actually moving forward pi over 8. So our first starting point is no longer 0, but it's pi over 8. That's going to be our first major point. I'm going to highlight that in purple. Okay. The next thing I'm going to do, this is my first point, is I have to add my sections. Okay. So notice here you have a denominator of 8, and over here you have a denominator of 4. What I would recommend is change that to an 8. 4 times 2 is 8. 1 times 2 is 2. So I'm going to be adding sections with a common denominator. So I'm going to use 2 pi over 8 as my section. So 1 plus 2 is 3 pi over 8. Okay, this is going to be my next major point. Okay, we're going to continue that until we have all 5 points and 4 of these sections in between. So plus 2 pi over 8, that's going to be 5 pi over 8. Okay, that's going to be highlighted. Plus 2 pi over 8, that's going to be 7 pi over 8. That point will be highlighted. Plus 2 pi over 8, that will be 9 pi over 8. That will be highlighted. Okay, a few ways you can check this is to make sure you have 4 sections in between, 1, 2, 3, 4. Those are like the quadrants on your unit circle, 1, 2, 3, 4. And then you have 5 numbers, 1, 2, 3, 4, 5, that are highlighted. That's 1, 2, 3, 4, and then 5 where you start, back where you started again. If I were to subtract this number from this number, so 9/8 minus 1/8, you will see that's 8/8, or in other words, 1 pi. The period should be the exact same if you do the difference between these two. So you have 1 pi, and sure enough, the period is pi. So you're good in that sense. Now let's go ahead and graph. This is our starting point for x. So our x is actually going to start here at pi over 8, and it starts at the center. So we're going to start our first point right there, and we're going up. Our next point is going to be 3 pi over 8. Here is 3 pi over 8, and it has to go to the very next point, which is way over here. Okay. The next point is 5 pi over 8, which is here. It's going to go back to the center. 7 pi over 8, down. 9 pi over 8, back at the center. So our graph here is going to look like this. One complete rotation. Okay. All right, hopefully this makes sense. I think it is a lot easier than what they're doing in Alex. All right, we're going to do another problem and then we'll be done. Okay, with this worksheet. Let's go ahead and look at this one. Now we're looking at everything. Don't worry about the range. You'll be able to see that when we graph. So the first thing I want to do is go ahead and rewrite this equation because we have to factor out this 2. So y is equal to 3 sine, take the 2 out, x minus pi over 8 plus 2. Okay? So if I distribute this 2 back in, I'm going to get the exact same equation that I have there. Okay, now let's go ahead and list everything. A is going to be equal to 3. Okay, B will be equal to 2, which means the period is 2 pi over B, which is 2 pi over 2, which is just pi, making the sections still pi over 4, okay, period over 4, and then making our points. Let's start at, where are we going to start at? This is a sine value, which means it starts in the center. Okay, we're actually going to have the exact same points that we did last time, because here, remember, we start at pi over 8. So I'm going to go ahead and put pi over 8. This I'm going to change to denominator of 8 times 2 times 2. This is the exact same work that we did before. I'm going to go ahead and do that real quickly. Hopefully you'll be able to follow me along. So we're going to add 2 pi over 8. We get 3 pi over 8. Okay. Plus 2 pi over 8. We get 5 pi over 8. Plus 2 pi over 8. We got 7 pi over 8. Plus 2 pi over 8. 9 pi over 8. It's the exact same thing. Now, here's the part that is different. I have not started graphing anything yet because this too makes a difference. Okay. First thing I need to do is identify where my center point is going to be. Because we have a vertical shift, our center is no longer on the x-axis. Our center is going to be up too. So this is going to be our new center. Okay. Look at why that's important. Because our center tells us where our A is. Remember, A is 3 units away from the center. So if our center is here, we're going to go up 1, 2, 3. This is going to be our top now. So remember that A has to be 3. A is the distance between the center and the top and the center and the bottom. So from here, 1, 2, 3. Here will be the bottom. So A is equal to 3. Okay, so here's our bottom. Our points are still going to be the same from here, and we're still going to be starting at the center, and we are going to be going up because 3 does not have a negative in front of it, so that means we start at the center and then we go up. So we're going to start at pi over 8, start in the center right here. Then we're going to go to 3 pi over 8, and then we're going to go up. So we're going to go to the next point, which is there. Okay. Then we're going to go to 5 pi over 8, and we're going back to the center. And then 7 pi over 8, we're going to go to the bottom, keep that pattern going. And then 9 pi over 8, we're going to go back to the center. So our graph now is very similar to the one that we had before, except it's shifted up too. Okay, so that's your answer for that one. Here is basically all the information that you need to know in a nutshell. This is your amplitude. Amplitude is always positive. The period is 2 pi over b. And then you have a phase shift. Notice this as C over B. That's when we factor that B out. That's what we're basically doing. And then D is our vertical shift. Notice that we didn't factor anything out of it. We just used that to help us determine where our center graph was. Okay, that concludes 4.5. I'm going to go ahead and do the worksheet. And make sure you have this information completely down before you move on to 4.6, because you need to know how to do this in order to do 4.6.